Now, how does the project life cycle look like? Once you get a project in any real world, it will be in this format. Okay. Where it is first understanding the business problem. I will take an example and make you guys understand. Then understanding where to get that data, how the data has been acquired, how much data can be wrong and correct. The wrong data needs to be transformed so that it can become correct data. Then you have to do the data analysis, which we call ED, exploratory data analysis. Then other transformations, which comes under feature engineering. Then modeling. Once modeling happens, you validate that model if it is correct or not. Once that happens, then you interpret the model. How do you interpret? There is always something called benchmark model. Your model should work better than that benchmark model. Benchmarking is something you can consider like a standardization across industries. So say suppose if I take an example of a bank, across bank for one particular problem, if they are solving that problem, there is a benchmark model. So most of the banks can see that benchmark model and accordingly they will go ahead and make sure that the model they are running is actually performing better than that benchmark model. And finally, if everything works fine, then we will go ahead and automate this process for which we need to deploy the model. And once the deployment done, now what is the purpose of doing all these things till the deployment? Basically, the purpose is in future, I can go ahead and predict it. So when you train a model, at that time you have the data with the target variable. The target variable over here means what you are going to predict. But that is the whole point, right? I am having data and on that I'm training my model so that in future, when I will not have that target variable, I can predict on that data. I'll make it very simple for you guys to understand. Say, for example, you have a small baby at home. I have a small baby now. I compare everything with him. Okay. So that baby will learn what is an apple, right? Now, to learn what is an apple, you need to show that baby several times the picture of an apple. All of us have gone through that stage where people have shown us what is A or how A looks like, what is B or how B looks like, right? What is an apple? Everything has been shown to us. And after seeing it, we have recognized because multiple times people around us have told us that this is the picture of an apple. We call this an apple. What is the spelling of an apple, right? So this is what you call target variable, like people telling us each and every time. Now, once we have learned it, later on, when people are not telling us, we can recognize it by seeing a picture or by going to the bazaar and market and seeing an apple over there and recognizing it an apple itself, right? That is how a baby learns. Very, very similar to machine learning. You can compare a machine with a baby over here and understand that is how machine learning works, where you are teaching the machine like these are the things you need to learn so that machine can later on go ahead and understand or predict, okay, previously I have learned these things. Now, what I had learned before, this thing what I am observing now, this seems very similar to that I had learned. So if that had a target variable, say X, then since this, which is very new to me, is very similar to that I had learned, this can also have the target variable as X. So it is predicting. Since both the things are very close, what it has learned and what it is seen now, that's why it is predicting, okay, this can be X. That is the prediction. So if you guys dive deeper into, say, image recognition, how images are getting recognized, a machine never tells with 100% confidence that this is this. Even the LLMs don't do that, whether it is ChatGPT or Claude. They will always tell you with probabilities. Like this looks like 80% chance that this can be an apple, but there is also this small 20% chance which can be an orange as well, because it is just matching with the say shape, not the color. The color is different, but the shape is very similar, right? So that is how it will tell you. 80% chance the image is an apple, 20% chance the image might be an orange. So that's how things happen or machine tells you when it needs to give you an answer. So this is called the prediction part. And this prediction happens after deployment. You are using the deployed model to predict on the unseen data. Now, how will you know whether the prediction is correct or not? So you will go back and you will see, now someone needs to tell the model, okay, you have predicted 80% as Apple, but let me tell you, it is 100% Apple. So that is how you are you are detecting what is the performance of your model. Like model has said 80% or 90% of by seeing a picture to be an apple, but 100% that is an apple, right? So this is how again you're comparing to see the performance of the model. Now, what if model is wrongly detecting 100% it is an apple, but model is saying no, it is only 10% apple? Then will go down, right? And that is
Excuse ma'am, your mic is muted. Excuse ma'am, your mic is muted.
okay. So as I was saying that we will take an example when it is about a use case where a poorly framed model can lead to a poorly framed problem can lead to a wrong model. And this is the place where most of us go wrong, because here we will take an example of, say, Zomato. Now, Zomato has, say, launched newly in Delhi, for example. It does not know how much discount if it gives to the customer. The tendency of customers will increase to shop more from Zomato rather than its competitor. If that is the scenario, what we are predicting over here, we are predicting that discount amount. So this is where things go wrong if you are not precisely saying what problem you are solving. It is not a very basic level. So you have to be very, very serious about the problem you are solving, and you have to dive deeper to understand if the problem is classification type, where it is like uh, 1 or 0, or regression type, where it is like continuous variables, like prices of quant quantities or prices of any item, these kind of things. Okay. So that becomes very essential when we are solving any problem using machine learning.